OK 啦
，OK 啦。
Good afternoon, everyone. Today we are going to present the GPS system. I'm Kitty. This is Kay, Queenie, Sui, Ai, Hong Cai. Let's begin. The Global Positioning System is a satellite-based navigation system made up of a network of 24 satellites placed into orbit by the U.S. Department of Defense. It provides locations and time information in all weather conditions. Also, the system provides critical capabilities to military, civil, and commercial users around the world. It is important to know how to use the GPS in order to make your life convenient. First, before using the GPS, you need to install the receiver that will help in request the necessary signals from the satellite. Second, you need to turn the receiver on. Third, select your region. Fourth, select your country. 5. Enter the elevations marking. You can finish these 3 tasks by using the control pad. Also, do not forget to input the current time and date, and then your receiver is ready to use. If you want to search a location, you need to enter the names of landmark, for example, Times Square. By doing so, you can find the locations of this place. Once you are done, you need to change the measurements of latitudes as well. Let's pass to Kay.
For GPS history, GPS was originally for military application, and the first satellite navigation system, Transit, used by United States Navy was first successfully tested in 1960. Before 1973, GPS was once called Navy Navigation Satellite System. In order to enhance the satellite positioning, the precision, U.S. started from 1973 to prepare for construction of GPS, using integrating ideas. After entering the plane, the system test stage started in 1989 to launch the orbital work satellite and completely finished in 1994. Between 1998 and 1994, the USAF total launched 24 satellites. In 1983, the U.S. President announced once the GPS build will develop for public use. After 2000, the Clinton administration decided to cancel the civilian signal interference. So nowadays, for civilians, the occurrence of GPS positioning was close to 6 meters. Now we can use GPS receiver come in a variety for format. The applications of the GPS can be classified as civilians and military. For example, for civilians, we can use it in computer and mobile communications, photograph, etc. And for military, we can use it for target tracking. Let's pass to Sui.
In the future, we think that the GPS can help us to travel around the world without spending money. We link the technology, bring you around the world. If you want to travel the world without spending a dollar in the future, you may follow the following procedure. First, you have to type in a signature spot of a country you want to go. Then the GPS will trade the image of that country. You just have to put your device on the floor, and the device will project the 3D image that signature spot around you. As a result, you may seem that you can see situating in the real environment, and you can see the historical building right in front of you. Although it is not an image, it is only an image and you cannot touch it. I'm sure you will be excited while you are using this technology. Now pass to Queenie.
will now move on to talk about how GPS works and what the theory is behind. GPS has 24 artificial satellites that orbit the Earth at the distance of 20,200 kilometers, transmitting video signals. Also, it takes 11 hours and 58 minutes to run around the Earth once, and the orbital inclination is 55 degrees. Then I will talk about the operation of the GPS. The three results of the operation of the GPS are: you will know the satellite, which you are understand it, your own position, and the time when someone sends you message through the GPS. Actually, the operation system of the GPS is according to the triangle position theory. It uses satellite video signal. The GPS receiver uses the time between collecting information from the satellite and sending information from the devices to calculate the distance. If the receiver detects three satellite, it will use 2D positional. If the receiver detects 4 or more satellite, it will use 3D positional. The receiver can also calculate your speed and direct, as it can receive your information continuous until your speed on your devices. And here is the operational formula of the GPS. The time of signal transmission time speed is equal to the distance of the satellite. Without the receiver, we can never use the GPS to position ourselves. Here are two types of receiver. One is the precision measurement receiver, and other one is the portable navigation receiver. Okay, let's move on to the next topic.
The GPS seems to be quite powerful in positioning humans on Earth. However, there are some limitations. Firstly, the GPS will be interfered easily. The weather condition will affect the electromagnetic wave, which lower the accuracy of the GPS in providing information. Secondly, the GPS will sometimes provide some wrong information, as it is hard to record every details of the road. The path planning may not be exactly the same with the real one, and the map data will not be updated as fast as the changes. Therefore, the GPS user may be misled by the information provided by the device. The third limitation is the regional restriction. If you want to use the GPS, you need to have the electronic map of the relevant area. Ready-to-use GPS coordinate update are providing electronic map and real-time map of the same position. If any one of these is missing, you cannot use the GPS. Therefore, the usage of the GPS is not that easy, and that is a challenge that people may not be willing to use this system if it is difficult to use. Let's pass to Hong Cai.
In order to improve the navigation systems, some positioning systems other than the GPS were developed. And there are European Galileo system, Russian Global Navigation System, that means the GLONASS, and the Beidao Navigation Satellite System, BDS. 4 navigation systems are using similar technology. They all rely on a fleet of satellites to accurately provide locations, that means launching satellites to the space. Also, 4 systems have some common uses. As we've mentioned before, applications of the GPS can be classified as civilian and military, and the other 3 navigation systems are also designed for these 2 purposes. Although the proportion of the use in military and civilian aspects varies among different navigation systems, civilian and military purposes are still the aim of them. Besides, 4 of them share the same aims: makes our life convenient and secure. Although the 4 navigation systems are using the same principles in positioning, there are quite a large number of differences between them. You can see from the table, according to the number of satellites, if they are fully developed, the GLONASS have the most number of satellites of 48, and the GPS have 24, Galileo has 30, and the BDS have 35. And the purposes, although they are all designed for military and civilian purposes, the GPS is mainly for military purposes for wars and anti-terrorism, and the Galileo is mainly designed for civilian, and it is immobilized during wars. The GLONASS is both for military and civilian purposes, but the top priorities belong to the government. And the BDS is mainly for military purpose at the beginning, but it changed to both military and civilian purpose at the end. And there are operational centers for all the four systems. And there are also, for the GPS, the GLONASS, and the BDS, there are one operational centers, and they are in USA, Moscow, and in China respectively. And there are two centers for Galileo system, and in Germany and in Italy. And the last one is the control over the technology. The GPS was under the US military agencies, and the Galileo is under European military agencies. The GLONASS is under the Russian government, and finally the BDS is under the Central People's Government of the People's Republic of China. But since the GLONASS is the most important and the most powerful one among the other three, other than the GPS, we want to compare the GLONASS with the GPS, which is our focus. The first point is that the GLONASS is more accurate than the GPS. The GLONASS have 48 satellites, that is double of the GPS. And it will be more accurate to position ourselves. And the second point is the GLONASS can avoid interference of enemies. The GLONASS have the frequency division multiple access. That means it will assign one or two frequency to individual and assign different code to them. And the GPS has the code division multiple access, which means that it relies on the frequency from different satellites, and each frequency has different code number. At last, the third point is the wider use for public. The GLONASS wins in this part. The GLONASS didn't have selective availability, while the GPS does. SA technology will reduce the accuracy of GPA positioning around 100 meters. For military, the accuracy of GPA positioning is just 10 meters or lower. And I will pass to Ayi to talk about the impacts of the GPS.
Okay, certainly the GPS brings convenience to us, and our group had classified the impacts of the GPS into three categories. The first one is the business aspect. A scholar has once claimed that the GPS is important to the economic development. For example, an airline company can find the starter route to any destination by using the GPS. Then, less fuel will be used and more flights can be used to conduct. This can also increase the satisfaction from the customer. At last, the profit will definitely increase. The second impact is the military success. Let's take the Gulf War in 1991 as an example. A scholar, Norman, said that the 1991 Gulf War was a very quick war thanks to advanced technologies such as GPS. In the war, the American Army was able to have the navigation successfully, hit targets precisely, and cut down friendly fire. The success will exactly rely on the function of the GPS in finding the enemy's location. The use of GPS in this war lies the foundation of the usage of the GPS for military purpose nowadays. Not only for militaries and business success, the GPS also helped individually. It enables us to find our position. Till nowadays, the GPS is important for us. As the GPS have backtracking function, we can still save if we get lost in the forest. You can save the location of your car while you wander through the woods. Unfortunately, if you get lost, you can trace the location to you and your car by using the GPS. If there is fire in the forest, the GPS can also direct the rescued to the scene of the disaster. As early as 1998, the GPS backtracking function has silent resetted to the airfield crash site. Those examples show that the GPS can help to keep you safe and even save lots of lives.
To conclude, essentially, GPS technology changed society both positively and negatively. GPS made navigation extremely easier. However, navigation remained an art because the proper use of a map and compass remain essential even with our GPS unit. On the positive side, GPS boosts economic growth. On the negative side, illegal and criminal activity enter the high-tech age. Therefore, we should use the GPS wisely and utilize its function fully to make our life convenient and secure. This is the end of our presentation. Thank you. Here are our records.